Welcome back, I'm John Furrier, host of theCUBE. Here at theCUBE's NYSE studios, of course we have our Palo Alto studios connecting Wall Street and Silicon Valley. This is part of our AI Factory series. This is a series exploring how AI infrastructure and the future infrastructure of computing is going to impact how we live, how we work, how we play. That societal benefits are multifold as new use cases emerge. Matt Kinsella is here, the CEO of Infleqtion, just went public this morning on the New York Stock Exchange. Part of our NYSE Wired program, a CUBE original. Matt, thanks for coming back. Thanks for being in the network and congratulations.
Thanks, John, it's great to be back.
So you're on the podium, ringing the bell this morning, opening up the stock market on your IPO. Congratulations. What's it feel to be up there?
Well, it was an incredible feeling, and we actually had a first in the more than 230-year history of the New York Stock Exchange. We wore flight suits and dressed up like Top Gun for the bell ring.
The need for speed, right?
Need for speed,
need for speed.
Right, yeah.
I'll be your wingman anytime.
You can be my wingman anytime.
Well, thanks for coming on. And this brings up a good point. I mean, like, it really highlights the speed side of it.
Yeah.
Quantum, it feels like it's been a science project moving at the glacier speed because of standard bodies, readiness, but now you're starting to see real alpha engineers really starting to roll out the early stages of the core software.
Yep.
You're starting to see devices, the role of GPUs, accelerating quantum computing.
Yep.
Use cases are coming. You guys have had a lot of success. Tell us what's new with you guys as you're public. You got to deliver the results. Yeah. So you're now a public company. We're going to see everything. Tell us what's happening.
Well, the reason to do this was, it's financing, right? We're going public as part of the financing, but we, raised $550 million as part of this transaction. And I look at this as now we've got the fuel in the tank to accomplish the mission. And our mission has always been to take quantum from the research lab and take it out into commercialization. And we've been following NVIDIA's approach to commercialization in that we have this very powerful core quantum engine that we first pointed at some near-term use cases that we actually have quantum advantage on today, like timekeeping, like sensing, and we can get into some of the applications of those products. And then building to the point where quantum computers are going to do all the amazing things that that we're all excited about, which we think will happen in about 2028.
It's funny, you mentioned NVIDIA at GTC in October in DC, which is kind of a special event for them because it had a lot of politics involved. Obviously, you had the China story.
Yeah.
Earlier in the year in March, GTC, he talked about quantum mainly because he made a comment at CES earlier in the year, right. And his comment to me when I talked to him about quantum, he said, John, every time I say quantum, the NVIDIA stock price goes up. Because when he didn't poo-poo quantum, he was really more like, it wasn't ready. He wasn't as bullish as he normally is, but he's had it on the roadmap for a while. So talk about your relationship with NVIDIA, how's that integrated to you guys? Because he was all guns blaring in October in DC around the role of quantum, the role that NVIDIA is playing in quantum, how that's creating a progression. Talk about the relationship with NVIDIA.
Well, they're an absolutely wonderful firm. A couple other folks were here with us as we rang the bell today, which was really exciting. And you spoke about NVIDIA's GTC DC. Hilariously, they had put together this pregame show, right, which they hired a bunch of ESPN College Game Day producers to do, and I was the quantum talking head on that. And while I was up there, Jensen came up and we started a quantum chant. And,
I was there for that. I saw that.
That was something else. But I'll tell you, it was what they put out into the world at that show was really interesting. It's called NVQ Link, and it's a way to link their GPUs to quantum computers because the cross currents between quantum and GPUs are massive, and so this is just a way to accelerate the ways for GPUs and QPUs to work hand in hand.
Talk about the relationship there, because most people don't understand the relationship with what NVIDIA is doing to quantum. Even though their GPUs aren't quantum,
right.
The scientists working on quantum are using them.
Absolutely.
So as a tooling, but also a platform. Talk about that piece.
It's a very, call it self-reinforcing circle, the benefits between AI and quantum. And so how does AI help quantum? Well, a lot of the work we need to do to make quantum computers useful is identifying where the errors are in our systems. And so we have enough qubits, they're just error prone. And actually the identification of the errors is relatively easy, but tracing them back to their root cause is actually an inference problem. So as we can utilize GPUs to do the inference to trace back to the errors, we can accelerate the correction of those errors and get to useful quantum computing. And then I don't ever think quantum is going to replace GPUs. I think why Jensen's excited about it is because he looks at it as a way to sell more GPUs. Yeah. And it's going to be quantum processors working hand in hand with GPUs to solve new problems. It's
not only picks and shovels for the creators and the scientists. It's also a key part of the system. You're saying.
Yeah. Absolutely.
All right. So talk about the how quantum's perform. You were last on theCUBE last fall.
Yes.
Milestones you had mentioned before you came on camera, some qubit milestones.
Yep.
Let's jump in the weeds for a little bit. Tell us about some of the technical accomplishments.
So we have two parts to our business. We have the sensing piece of the business, then we have the compute piece of our business. On the sensing side of our business, we already have quantum advantage. These are products that do things that classical products can't do, and we announced a big contract with NASA 2 weeks ago, where we're sending some quantum sensors into space to sense gravity on the Earth's surface, and in fact, changes in gravity on the Earth's surface with extreme precision. And you can infer some pretty interesting things about what's happening on and below Earth's surface if you can see changes in gravity, digging of tunnels, movement of heavy materials like nuclear materials, a lot of interesting things. On the quantum computing side, it's really a race. We need to get to 100 logical qubits. That is when computing becomes useful, quantum computers become useful. We announced in October of last year that we're at 12. Our roadmap calls to get to 30 by the end of this year and to 100 by the end of 2028, and that's when we'll start to see some of the early applications of quantum computing.
Share a little bit of what that looks like, that picture. Share what you guys are thinking as you look at your milestone out with 100 qubits. What does that look like?
So at 100 logical qubits, and just to define the terms, logical qubits are error-corrected, pristine qubits that can do interesting things. Like physical qubits are error-prone, you can't use them. So 100 logical qubits will be more than 100 physical qubits, but let's just focus on the logical qubits. 100 logical qubits. At that time, we think we'll start to be able to do some interesting things in material science. And so material science is quantum mechanical in nature. You're smushing molecules together, the electrons are coming together, that's quantum mechanical, that's very challenging for a classical computer to model. Easy for a quantum computer to model. And so it's the development of new materials, like a battery that would make your iPhone last for a year instead of a day, right? That kind of thing. So that's what I
love about your company is, one, I love the NVIDIA connection, that's why I wanted to highlight that. But two, you guys are taking a very strong innovation approach by shipping and moving the needle and commercializing. So you get the space deal. What's it like on the business front right now? Can you share a little bit about some of the progress and momentum?
Sure. So in 2024, we did $29 million in revenue. We announced that in 2025, we were booked or awarded $50 million in bookings or awarded revenue or awarded business. That sets the stage for good growth going forward. And so we're really commercializing the quantum sensing side of our business. We've sold 3 quantum computers, even though they're not yet commercially useful. And then we're marching to the point where those quantum computers are going to get useful.
And so funding, the funding event, obviously there's more money in the capital markets here. You have the runway. You product focus, and the product focus on the sensing side. How's that look? What's the progress there? And the quantum, you gave that kind of roadmap. What's the roadmap look like on the sensing side?
The sensing side. The nice thing about our technology, which is the neutral atom quantum modality, is it's very flexible. And so our quantum core, we use the same underlying technology for all of our products. And so the most commercialized of our products is a quantum clock. And that keeps time about 1,000 times more precisely than any other clocks out there. Next up is a quantum RF antenna. Same underlying technology. You might say, like, what the heck does a clock and antenna have to do with each other? In the case of quantum, they're basically the same thing, just slightly different usage. And then these sensors, like the one we're putting into space, are probably the most robust thing you can do with quantum sensing. And then it's just a hop, skip, and a jump to turning that into a computer. Same underlying technology. And so it's this continuum of complexity, call it, from clocks to computers on what you can do with quantum technology.
So you have upgrade headroom in space.
Yeah, basically,
what's it like in the company? What's the culture like? Obviously a lot of development, breakthroughs. What's it like? What's the...
I mean, I'll give you a day in Infleqtion. I'll tell you, when I walk in the door, the average IQ plummets because these are the smartest human beings in the world.
Exactly.
But I mean, our founder Dana will be on his wall signing, solving Maxwell equations, and I'll walk in and be like, Dana, you forgot to carry the one.
Exactly.
So I'd say it's a mix of a lot of fun, but really heavy, both science, but importantly, engineering and commercial focus. And so I was the first investor in this company back in 2018 before I joined full-time as CEO. Having been an investor for a long time, I know it's very challenging to transition from a research-focused company to a commercial-focused company. So I made sure that commercial DNA has been embedded in the business from the moment I invested in it. And so we are always focused on shipping product on time. You can't send a team of physicists with each product. You can't turn the screwdriver to make it better. You have to put pencils down and ship. That's a hard transition to make, and so that's embedded in our DNA going back for 8 years.
I have to ask because you're the smart. You might not be the smartest guy in the room when you're in the company, but I'm sure when you're out with your friends, with the kids and other families, it's like, what does he do? He's a rocket scientist. Demystify quantum because people think it's something different than it really is. Some people, well, it's a bunch of scientists and it'll crack all the codes. Where are we? What's the reality of quantum computing today? How would you describe it?
At the highest level, when we talk about quantum, we are talking about the world of the very small, so the atomic and the subatomic. And there's a whole different set of rules down there called quantum mechanics. And when someone says I work in quantum, it means they're trying to turn the properties of quantum mechanics into useful products that will help us as humanity. And so what we do is we turn those properties of quantum mechanics into clocks and RF antennas and sensors and computers. So really that, at the end of the day, is what it is. And if you look at history, all forward progress usually starts with some breakthrough in physics, right? We had the classical physics that were levers and pulleys and things like that built the classical world. And then you had the laws of thermodynamics, which led to the Industrial Revolution, the laws of electromagnetism, which led to our computers and our internet. The one unexplored area of physics is quantum. And so this will lead to a whole new generation of human progress as we can start to tap into that power.
And I like how you brought in NVIDIA. I want to go back to that. And so now talk about the distinction between GPUs and what NVIDIA is doing with what they've done with high performance computing, which was a slow moving industry of power workstations basically to distributed nodes of massive supercomputing capability. How does that vector into the synergy of quantum?
Well, there's that self-reinforcing loop where GPUs will help us get to useful quantum computers faster, but when I look at the future and I think about what the data center looks like in the future, it's been fascinating to watch how GPUs have just sort of proliferated into a data center that was dominated by CPUs historically, right? And now GPUs are a major player, but you still have CPUs. I believe QPUs, quantum processors, will come into the data center in a very similar way and work in tandem with CPUs, GPUs, and QPUs, and you're going to send problems in the form of workloads into data centers. It's going to get chopped up and sent to the appropriate part of the stack to be solved by what solves it best. No one's going to care that it's quantum. We can just do new things that we hadn't been able to do from computing.
Yeah, one of the big things about the AI wave that I love, generative AI wave, certainly NVIDIA's enabled, others are doing the model, frontier models, is it abstracts away a lot of the interfaces and constraints around usability.
Yep, absolutely.
But at the same day, what you're saying here is that quantum will be in the data center, but it's also going to accelerate distributed computing as we know it.
Absolutely.
So edge is now on the table.
Very much so,
I know I've been cheering from the top of my lungs. It's going to come to the edge with telecom convergence. What's that look like from a customer standpoint? How ready are they? That's a big topic in quantum readiness, mostly from a security, private key, and making sure the encryption, post-quantum encryption market. What's the market and customers doing? I see at the high-end NASA, I see that clearly. And what are they doing? What's their back end? What's the consequence? It's a moment of consequence for them, because now they have all new capabilities. What are they doing? Are they reorganizing? Are they rethinking? How are they scoping their landscape of operating these large scale, which will become large scale distributed networks?
Yeah. The edge is really interesting for quantum. And actually, not to introduce a totally new topic here, but what we've been able to do is take software that we wrote for quantum computers and start to apply it on GPUs. And it actually has shown to unlock some incredible capabilities in GPUs, particularly NVIDIA's Jetson edge-deployed GPUs. And what it allows you to do is actually to expand the context window of those GPUs, so they can ingest more information and process more information at the edge than they otherwise would be able to. It would get overwhelmed. And so we've started to actually deploy our software on NVIDIA's GPUs and monetize that in the form of edge-deployed sensors for the Army and the Navy, allowing them to ingest either real-time streaming data from sensors or real-time RF streams that would normally overwhelm an edge GPU. And so it's been kind of incredible to see a quantum-inspired software loaded onto classical GPUs and showing performance advantages. So it's kind of an interesting fast-forwarding to quantum advantage in the form of software.
Yeah, you're pulling forward the capabilities. What I like about that is that if you think about the edge, and this is why I love what NVIDIA is doing, what you're doing, is that the data coming in is new data.
Yeah, that's right.
Images, video.
Exactly.
It's a lot of volume.
A lot of data, a lot of volume.
High velocity, ton of volume.
Yeah.
It's not trained.
No.
It's new data, it's fresh.
Exactly.
It needs to be trained, understood, inferred, reasoned on.
Exactly.
Agents are coming in, so a whole wave of new intelligence software is coming.
Yep, that's exactly right.
Explain how that's all going to get, because it sounds simple to understand, or maybe not, but it's actually complex.
Yeah. Well, your point is exactly right, and that's actually one of the bottlenecks of large language models has been training data, right? And there's been we're kind of running out of stuff to train these models on, and quantum will unlock more training data. And in that, you said we're ingesting more data that's real time, it's brand new, it hasn't trained, but also quantum computers will excel at creating synthetic data. so new data to train these models on. And again, that's another great cross-vector of quantum and classical computing.
When you guys look at your finances, obviously just what we were just riffing on in real time in theCUBE here is that there's more headroom for you guys. You don't know what you don't know.
Right.
So how do you think about that as CEO? Obviously a lot of R&D going on. How are you prioritizing, kind of watching how the world turns, seeing around the corner?
Right.
How much of your time is thinking about these things, and how do you guys approach it?
Yeah, I try to spend a lot of time imagining what the world is going to look like in the future, but having to come at it with a great degree of humbleness, because no one would have anticipated what classical computing could do, right? Who would have thought, when the Apple IIe came out, that you'd have GPUs doing what they do. So I have to understand that it will be hard to predict what humanity will do with quantum, but our strategy has always been, let's focus on the things that are obvious in the near term, and that's quantum sensing, and then let's get these quantum computers useful enough to get them out of the developer community and then have them start to figure out.
So basically your strategy is keep your options open, knock down what you can knock down on the commercial side, take what you can get with the market, ride that wave, see what happens.
And eventually it'll become more clear as to exactly what to focus on, but right now we're still pretty early in the market development of quantum.
Okay, so the IPOs today, stock rang, I heard the second bell when you guys made the first trade. What's next? What's on the roadmap? What's the use of funds? What's the strategy? What are you optimizing for?
Well, it's really continuation of our existing strategy, maybe with some slight acceleration, but part of this is to make sure we have a war chest on the balance sheet to bring this important technology out into the world. But if I had to classify the uses of this funding, it would be in two big buckets, R&D, and R&D comes in two flavors for us. We have one, think of it as like an up and to the right, and the other is to a down and to the right. The up and to the right, for our computing, build more qubits, make those qubits more powerful, get to 100 logical qubits. The down and to the right is for our quantum sensing equipment. Those are already quantum advantaged, so it's really about making them cheaper and smaller, and so that's the down and to the right curve. And then sales and marketing, there's a huge opportunity out there. We got to invest behind it.
So you got a tailwind on the sensing. Get commodity type pricing for volume.
That's right.
And get the tech up high, kind of like the NVIDIA strategy. Kind of like the similar path.
That's been our. I mean, I've told this to Jensen. We are kind of copying their commercialization strategy. They went after graphics first, right, in the form of gaming, and then crypto mining, then physics, then ultimately crown jewel of large language models. We're doing clocks, QRF, and ultimately quantum computing.
Jensen is one of my favorite interviews I've done. Andy Jassy's another one I've ever interviewed. Andy Jassy had an expression called, if you want to pioneer the future, there's so many words he said, I'll paraphrase. You have to be willing to be misunderstood for a long time.
Yeah, I like that.
Jensen kind of said that almost same thing, but in a different way, that CUDA has been around for years. This is not new for NVIDIA.
No.
And just now the world's waking up. So I guess my question and final question for you is that, what are you misunderstood about and what are you okay with?
Well, I do think there's a huge misunderstanding that quantum is just this thing that's going to happen in the future. The quantum sensing market is real, and we are addressing it in size today. And I think the other thing that is misunderstood is useful quantum computers are coming sooner than people anticipate. And so we all need to prepare for Q-Day. We all need to prepare for the days when quantum computers are going to be able to break encryption, and we will get there. But this is happening.
And what should people do to prepare?
Well, start to get to post-quantum encryption for sure. And unfortunately, there's this scary thing called harvest now, decrypt later, where people are stealing encrypted data and sitting on it, and then we'll
waiting for the day.
Waiting for
Q-Day.
Yeah, so there's not much you can do about that, but new data, you start to shift to quantum encryption.
Well, Matt, congratulations on the IPO.
Thanks,
great
John.
to see you again.
Yeah,
you got a spring in your step. It's a moment of consequence here at the NYSE.
Yeah.
Thanks for coming
really
in. Great
exciting.
to see you. Congratulations on your IPO. Again, another tech IPO here. theCUBE's got you covered here. The NYSE Wired program at CUBE Original. We break down the leaders between capital markets and technology. Of course, theCUBE's doing its part. I'm John Furrier. Thanks for watching.